Hi students, let's look at this question here, which was taken from the year 2000, paper 1, question 11 of the A-level paper. I believe this question is on differentiation. Let's say you can do this proficiently. So it's given that x and y satisfy this equation here. We are asked to find the value of y when x is 1. So what we do is you just have to replace x into the equation, right? Then we just need to solve for our y, right? That's about it. So when x equals to 1, what we get is tangent inverse 1 plus tangent inverse y plus tangent inverse y equals to 7 over 12 pi. Okay, then this will be okay. This is 2 tangent y, so we can just sub them up. Then just remember that tangent inverse 1 is just pi over 4, so this will be 7 over 12 pi minus pi over 4, 1/4 pi. It's just 90 degrees, 45 degrees. Okay, this is 1/4 pi. That will give us 1/3 pi. So from here, what we do is tangent inverse would then be tangent inverse y would be 1 over 6 pi. So we just bring the tangent both sides. This would be tangent pi over 6, which is 1 over root 3. All right, so it's just 1 over root 3. Next one is express tangent x inverse xy in terms of x and y. All right, and dy dx. So don't forget to use chain rule and also implicit differentiation. So the outer layer, then there's the inner layer here. Then we need to use product rule for the inner layer. So this tangent inverse xy will just be 1 over, just using the MF, so 1 over 1 plus x y squared, the outer layer. Then the inner layer will be, keep the one on the left, differentiate the one on the right. Then keep the one on the right, differentiate the one on the left. Okay, so I'll just do this for you. So let me label all the steps here. So when you differentiate the outer layer, you'll get this 1 over 1 plus xy squared. Then the inner layer will be this, where this is just, if this is u and this is v, this is u dv dx plus v du dx. Okay, that's it. So from here, what we get is just simplify it. We'll get 1 over 1 plus xy squared. Then this will be x dy dx plus y. Okay, so this is the derivative of tangent inverse xy, which is this derivative here. Okay, this is the same expression. So show that when x equals to 1, dy dx is given this. So we need to differentiate this once. Okay, then we need to, which we don't need to differentiate this because we already did this in the second step here. So what we're going to do is just take this again, then differentiate this with respect to x. Okay, then we just need to replace values in, which is including the value x equals to 1, then y equals to 1 over root 3. So here we're going to just differentiate with respect to x, right? So tangent inverse x will just be 1 over 1 plus x squared, not an issue. Then this one will just be our implicit differentiation, 1 plus y squared. We just add a dy dx behind. Okay, so this is it, dy dx. Then this last one we just take from 2, which is this expression here. Okay, that's it. And then differentiating 7 over 12 pi will just be 0. This is it. Okay, so then what we need to do is just replace all the value that we found just now, which is when x is equals to 1 and y equals to, what was y? Y was 1 over root 3. Okay, y was 1 over root 3. So just replace all this in. We should be able to find our dy dx. So 1 root 3, this expression here, 1 over 1 square. So sub into 1. Okay, it's 1 over 1 plus 1 square plus 1, 1 plus 1 over root 3 square dy dx plus 1 plus 1 over 1 over root 3 square. Then this is 1 times dy dx plus 1 over root 3 equals to 0. Okay? So just simplify this. Key in calculator, you get this value here. That you need the exact value, right? So you just so there you go. We need to make dy dx a subject. So expand this guy, expand it in. Okay, then we'll see what we get here. So we just sum this up. This will be 3 over 2 dy dx. Add them up, then this will be negative 3 over 4 root 3 minus half. So multiply by 2 divided by 3. Will give us dy dx equals to negative 1/3 minus 1 over 2 root 3. Okay, shown. So that's how I do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.